First of all, I welcome all the students and the participants who are attending this live lecture. Today in this live lecture, we shall solve the problems based on their real analysis. In that real analysis, some integrable functions. That means we have to solve some theorems, remaining theorems. Yesterday we have solved one theorem. If a function is a continuous, then it is integrable. This is one most important theorem which we have studied in the last lecture. दिगंबर इमदे, गोलप, ऋतुजा, योगेश्वरी वाघमारे, राहुल वाडकर एवढेच आहेत का रे? ऐश्वर्या अंधारे मुलं एवढेच आहेत का? थांबा, तुमचे आता मी आन्सर घेऊन स्क्रीनशॉट घेतो. मला मुलं जे ऑप्शंट राहायला लागलेत ना, त्यांना तुम्हाला हॉल तिकीट देऊ नये लागतं. परीक्षेला नाही बसू देणार, आता ठरवलंच आता. ठीक आहे. सो टुडे वी शॅल डिस्कस द सम इंटिग्रेबल फंक्शन्स, theorems on some integrable function. This is the chapter number 2, unit number 2, and then we shall discuss the integration and differentiation. So before starting the integration and differentiation, we shall solve the theorems based on the series, some integrable functions. Now these total theorems are based on the integral is a limit of a sum series. This is the definition of the sum of integration. These are the parts which already we have seen. This is the second definition of the integrability, which is based on the Riemann sum. Darboux condition. These are the condition of the integrability of a function. Existence of the limit of the Riemann sum. If there exists a limit of the Riemann sum, then it is also called as the integral of the given function. Now we shall discuss the next theorem. I think theorem number, it may be 6 or 7, whatever may be. Now we shall discuss next theorem. See this theorem. कालचाच थेरम कालचा तोच परत येत होता. कंटिन्युअस इफ अ फंक्शन इज, बरोबर आहे, एव्हरी कंटिन्युअस फंक्शन इज इंटिग्रेबल. दॅट मीन्स yesterday we have seen every continuous function is integrable. Means if a function is a continuous in the closed interval AB, then we also proved that function is differentiable. That theorem is also going repeated today, so I have removed it, and I removed that theorem. Actually the theorem number 5 is that, write down the statement of the theorem number 5 is, if a function is monotonic on closed interval AB, see this, it is not continuous. Main difference is that if a function is a monotonic on closed interval AB, then prove that it is integrable on closed interval AB. It is integrable on closed interval AB. See this. See this. Actually, what we have to prove? If a function is monotonic on closed interval AB, monotonic, it may be increasing, it may be decreasing, but it may be, suppose, decreasing. So we consider it may be increasing, it may be decreasing. Y is equals to f of x. Suppose this function is monotonic in closed interval AB, in closed interval AB. then we have to prove that it is the integrable. फरक लक्षात आला का रे स्टुडंट्स? What is the difference between yesterday's theorem and statement of yesterday's theorem and today's theorem? Yesterday we have seen every continuous function is integrable. Here in this case, if a function is monotonic on the closed interval a b, it may be increasing, it may be decreasing, then we have to prove that it is integrable. Okay, now see this. Suppose we have to prove this theorem, we have to prove this theorem when f is monotonic. Suppose we have to prove this theorem, f is monotonic increasing, it may be decreasing, no problem, monotonic increasing. Monotonic increasing means in that case the value of f of b, see this monotonic increasing means क्या होता है, मैं यहाँ पे फिगर लगाता हूँ अभी. Monotonic increasing in this way. Suppose what is mean by monotonic increasing? That is the value of f of b is greater than or equals to value of f of a. So we can say that function is a monotonic increasing. So no problem. Let clearly, if a function is a monotonic increasing, then it is a bounded. So clearly f is a bounded, and according to the condition of the boundedness, you know that for given epsilon greater than 0, there exists a number eta, such that eta is less than epsilon divided by f of b minus f of a plus 1. हे एक आपण कन्सिडर केलेला नंबर घेतला आहे, कारण हेच का घेतलं तर नंतर आपल्याला टर्म कॅन्सल करायची आहे म्हणून अशा पद्धतीने घेतलेले आहेत. I have taken, actually such terms are we have taken in number of times, so I can't go in the detail for this consideration. या कंसिडरेशन साठी अपन यहाँ पे डिटेल जाने की अभी जरूरत नहीं है, बहुत बार हमने इस तरह के कंसेप्ट ले लिया है. Now see this. Suppose if we consider this inequality as a 1, sorry, now we choose a partition P which is given by the points x0, x1, x2 dot 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 xn of closed interval AB with the norm mu of P which is less than, suppose, eta or delta xi. Suppose delta xi is equals to eta. Now given, but the function f is monotonic increasing, but f is a monotonic increasing, therefore we can write क्या होता है देखो, f is a monotonic increasing means generally f of b which is equals to capital M and f of a which is equals to small m generally. So we can write capital Mi is equals to f of xi and small mi is equals to f of xi minus 1 for I is equals to 1, 2, 3 dot 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 n. If the function is a monotonic increasing, then generally its upper bound is f of b and its lower bound is f of a. So capital Mi we can generally written as f of xi and small mi can be written as f of xi minus 1. Now we know that u of p comma f minus l of p comma f according to the definition. चला रे सांगा बर u of p comma f ची काय definition आहे? How we can write in the summation form? I is equals to 1 to n capital Mi into delta xi minus L of p comma f means I is equals to 1 to n small mi into delta xi. So we can take the common I is equals to summation I is equals to 1 to m capital Mi minus small mi and common is also delta xi. Now here capital Mi means according to the condition summation I is equals to 1 to n capital Mi का मतलब होता है f of small xi. हाँ बरोबर आहे ओमकार बिराजदार व्हेरी गुड एकाचाच आन्सर आलं रे. आणि स्मॉल mi का मतलब होता है सीरीज f of xi minus 1 into delta xi series. But you know that delta xi which is given by eta, you know that the delta xi mu of p means largest subinterval which is eta and less than or equals to eta. So we can write u of p comma f minus L of p comma f which is less than or equals to summation I is equals to 1 to n f of xi minus f of xi minus 1 into eta. See this, because delta xi is less than mu of p is less than eta, लेस देन है क्या, लेस देन और इक्वल्स टू है, अभी एक बार देखना पड़ेगा आपको. इट इज लेस देन ईटा, mu of p is less than eta. So here it is given that less than eta, so we have to write it in the form of less than eta. So which is less than eta into summation I is equals to 1 to n. We can write f of xi, f of xi means generally it is given by f of b minus f of a. Eta is taken out of the summation. See this, summation f of xi I is equals to 1 to n means f of b summation f of I f of a. So put this value of the eta, so we can write u of p comma f minus L of p comma f which is less than, put the value of eta means epsilon divided by f of b minus f of a plus 1 into f of b minus f of a. So it gives the value. See, this denominator is greater than the numerator, so we can write u of p comma f minus L of p comma f which is also less than epsilon. And if this u of p comma f minus L of p comma, see this, हे कॅन्सल नाही होत, लक्षात घ्या, परंतु the denominator is greater than the numerator, means f of b minus f of a and f of b minus f of a plus 1, this goes to denominator is greater than numerator. So this value of a fraction is again less than this value. So we can write this is approximate equals to less than epsilon. So u of p comma f minus L of p comma f is less than epsilon. So we can write hence the function is integrable and hence proved. आइए देखो इस तरह से हमने यहाँ पे थ्योरम डिफरेंट थ्योरम ले लिए है। अभी क्या करना है, मैं कुछ नोट आपको बताने जा रहा हूँ। वो एमसीक्यू के लिए बहुत इंपॉर्टेंट नोट है, यू मस्ट नो। सो राइट डाउन नोट, एक एक नोट मैं बताता हूँ। रिमार्क, वी कैन राइट नोट और रिमार्क। सी दिस, हाँ ओके, रिमार्क। This is important remark. You must know, if a function, if f is integrable on closed interval AB, if and only if for epsilon greater than 0, there exists a delta greater than 0 such that if p comma p dash are any two partitions of closed interval AB, with mu of p less than delta, then we can write S of p comma f minus S of p dash comma f, which is less than epsilon. See this, अगर हमारे पास किसी भी इंटरवल के दो पार्टीशंस होते हैं, फर्स्ट पार्टीशन इज p डैश, सपोज फर्स्ट पार्टीशन इज p, second partition is p dash, then note that the Riemann sum of both the partitions having the difference is always less than epsilon, means difference is always less than, means which is minimum. याद रखना है, पर फिर से मैं बताना हूँ, if there are two partitions, see this, P1 and P dash, suppose P and P dash are the two partitions of the closed interval AB. If we take the Riemann sum of a first partition, again Riemann sum of a second partition P dash, and if we take the absolute difference of both the Riemann sum, then definitely we can say that difference of both the Riemann sum is always minimum, which is nearly about 0. We can say that less than epsilon. हे एक लक्षात ठेवा, जर दोन पार्टीशन तुम्ही एकाच इंटरवलच्या वेगवेगळ्या पद्धतीने घेतलात आणि त्यांचे जर तुम्ही रिमान सम काढून डिफरन्स घेतलात, तर लक्षात ठेवा तो डिफरन्स ऑलवेज लेस दॅन 0. Sorry, always less than epsilon. That may be positive. Absolute value of that difference must be positive, but which is nearly about 0 or less than epsilon. So second, if a function f is continuous, then for given epsilon greater than 0, there exists डेल्टा ग्रेटर देन 0 सच दैट अगर कौन सा भी फंक्शन कंटिन्यूअस होता है देन देयर एग्जिस्ट कंडीशन समेशन I is equals to 1 to n f of ti into delta xi minus integral from a to b f dx which is less than epsilon. See, this is a condition. If a function is a continuous, then definitely we can say that this absolute value, that is the Riemann sum minus its integral, इंटिग्रलची आणि रिमान समची व्हॅल्यू याचा डिफरन्स हा नियरली अबाउट 0 असतो, मीन्स स्मॉलेस्ट असतो. द व्हॅल्यू ऑफ इंटिग्रल अँड द व्हॅल्यू ऑफ रिमान सम, द डिफरन्स इज, or we can say that the value of integral and the value of Riemann sum which is nearly about equal. That means the difference is always nearly about 0. We can say that लेस दॅन इप्सिलॉन. ही एक नोट लक्षात ठेवा. सेकंड, कंटिन्युअस फंक्शन असेल तर. थर्ड नोट, इफ अ फंक्शन एफ इज अ मोनोटॉनिक, हा तर ते तर थेरम स्टेटमेंट आपण घेतलेले आहे, परत लिहायची गरजच नाही आहे. इफ अ फंक्शन इज अ मोनोटॉनिक ऑन क्लोज्ड इंटरवल ए बी देन इट इज अ डिफरन्शिएबल on okay. Now see this next note. A bounded function f having a finite number of points of discontinuity on closed interval AB is integrable on closed interval AB. Okay, if a function is a bounded and having a finite number of points of discontinuity on closed interval AB is also integrable on AB. But the converse of this theorem or converse of this note is not true. Okay, next, for a bounded function f is integrable on closed interval AB if the set of points of discontinuity has only a finite number of limit points. See this, a bounded function f is integrable on closed interval AB if the set of points discontinuity has finite number, means it may be in minimum number, it may be in countable form. See this, next we shall discuss the problem. Okay, these are the different notes. Now we shall discuss problem based on this example. Which is also important example. What is that here? show that the function f defined as follows. Show that the function f defined by f of x is equals to 1 upon 2 raised to n, when condition कसे आहे 1 upon 2 raised to n plus 1 which is less than x is less than or equals to 1 upon 2 raised to n, and in this case n is comma n is equals to 0 comma 1 comma 2 dot 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 n up to the infinity we can take, and f of 0 is equals to 0 is integrable on closed interval 0 to 1, although it has an infinite number of points of discontinuities. See this is the important problems. You must know what is the concept of this problem. Show that the function f of x is denoted by 1 upon 2 raised to n, when 1 upon 2 raised to n plus 1 is less than x is less than or equals to 1 upon 2 raised to n. The definition of the function f of x is equals to 1 upon 2 raised to n. The condition is that 1 upon 2 raised to n plus 1 which is less than x is less than or equals to 1 upon 2 raised to n, and the value of this function is 0. F of 0 is equals to 0. F of 0 is equals to 0. This is also given value. Then we have to prove that the function f of x is integrable in 0 to 1, although it has a number of discontinuous point. यामध्ये discontinuous point 0 to 1 मध्ये infinite number of discontinuous point आहेत, कारण 1 upon 2 raised to n plus 1 is less than x is less than or equals to 1 upon 2 raised to n. If we put the different values of n, then we get the number of discontinuous points, infinite number of discontinuous point. Then also we have to prove this function is integrable, that means according to these conditions, that is theorem condition note number 3, or you can use note number 4. Okay, note number 3 or note number 4, it is also bounded. A function is a bounded function f is integrable on closed interval a b if the set of points of discontinuity, it may be in finite number. इथं finite number म्हटलंय, पण infinite number ला सुद्धा discontinuous होतं. त्याचं एक example आहे. Now we shall solve this example. Here solution. Given function is bounded in closed interval 0 to 1. We have given the function is bounded in between 0 to 1. Now, and f of x is equals to 1 upon 2 raised to n. We can take the value of x when 1 plus 1 is less than x is less than 1 upon 2 raised to n. And we can take n is equals to 0, 1, 2, 3 dot dot dot. See this? Okay. अगर हम फर्स्ट वैल्यू लेते हैं 0 also, and also we have given and f of 0 is 0, it is also given. Now if we put एक्स एन इज इक्वल्स टू 0. चला रे यामध्ये ठेवा बरं, एन इज इक्वल्स टू 0 ठेवल्यानंतर एक्सची रेंज काय येते सांगा बरं रे. एक्सची रेंज काय येते सांगा. इफ वी पुट 0 in the f of x, then what will happen? So f of x will be, see this, f of x is equals to 1 upon 2 raised to n, means 1 upon 2 raised to 0, 2 raised to 0 means 1, 1 upon 1 means again 1. When, अभी इसकी रेंज देखना है आपको. 1 upon 2 raised to n plus 1 means, see this, 1 upon 2 raised to n plus 1 means 1 upon 2 raised to 0 plus 1 means 1 by 2 is less than, x is less than or equals to, यहाँ पे less than or equals to है राइट साइड को. 1 upon 2 raised to 0 means 1 upon 1. मीन्स आपको ये याद रखना है कि f of x की वैल्यू 1 आती है. कहाँ से कहाँ तक? 1 by 2 से लेकर, see this. See this, suppose this is a 0, this is 1, this is x-axis, this is y-axis. Then the function, कैसा है फंक्शन देखो, 0 to 1 by 2 तक f of x की वैल्यू 1 है, 1. जीरो से लेकर 1 by 2 तक, बट लेस देन 1 by 2. 1 by 2 से लेकर 1 by 2 से लेकर 1 मिनट, 1 by 2 से लेकर 1 तक फंक्शन की वैल्यू कितनी है? 1 है. देखो सी दिस. ओके, अभी आपको सेकंड निकालना है. इफ एन इज इक्वल्स टू 1, चला रे स्टुडंट नीट सांगा, एन इज इक्वल्स टू 1 असेल तर व्हॅल्यू काय येते? नाउ पुट दिस व्हॅल्यू, दिस इज एफ ऑफ एक्स. ही डायग्राम पहा म्हणजे तुम्हाला लक्षात येतं. नाउ 1 by 2 त्यामध्ये इन्क्लूड नाही आहे, 1 इन्क्लूड आहे पण 1 by 2 इन्क्लूड नाही. 1 by 2 इन्क्लूड नसल्यामुळे इथं आपण काय करू, हा स्पेस देऊ. Okay, now second. Now if we put n is equals to 1, then what will happen? If we put n is equals to 1, then f of 1 is equals to 1 upon 2 raised to 1 means 1 by 2. And its range is, again we shall discuss when, आता n is equals to 1 by 2 ठेवलं तर काय येतं? 1 upon 1 plus 1 means 1 upon 2 raised to 2 means 1 by 4. 1 by 4 means 0.25 is less than x is less than or equals to, इथं काय येतं रे? 1 upon 2 raised to 1 म्हणजेच 1 by 2. हा बरोबर आहे. निर्मोही देशमुख, ऋतुजा देशमुख करेक्ट आहे. यांचंच लक्ष फक्त व्हिडिओवर आहे, बाकीच्याचं लक्ष नाही, काही नाही. मग आता इथं पहा 1 by 4 to 1 by 2 पर्यंत, इथं समजा 1 by 4 असेल, सपोज दिस इज 1 by 4. डायग्राम काढा नंतर 1 by 4 पासनं हे 1 by 2 पर्यंत त्याची व्हॅल्यू किती येते? 1 by 2. ही डायग्राम काढा, लक्षात येतं तुम्हाला. द व्हॅल्यू ऑफ अ फंक्शन एफ ऑफ एक्स इज 1 फ्रॉम 1 to 1 by 2. 1 by 2 to 1 by 4 ची व्हॅल्यू 1 by 2 आहे, म्हणजे फंक्शन डिसकंटिन्यूअस है. ग्राफ बघा, तुम्हाला लक्षात येईल. इफ वी सी दिस ग्राफ, अभी देखो यहाँ पे जो भी आप ग्राफ देख सकते हो, ये जो ग्राफ आपको दिखाई दे रहा है ना, ये ग्राफ कंप्लीटली आपको डिसकंटिन्यूअस फंक्शन दिखाता है. सी दिस, देखो कंप्लीट डिसकंटिन्यूअस है, कंटिन्यूअस नहीं है, ब्रेक है उसमें. ओके, नो प्रॉब्लम. नाउ इफ वी पुट n इज इक्वल्स टू 2, वी शैल राइट f ऑफ 1 की जगह पे x ही लिखते हैं. x इज इक्वल्स टू, हाँ 2 ठेवल्यावर काय येतं रे सांगा बरं स्टुडंट्स? 1 अपॉन 2 raised to 2 when 1/2 क्यूब यांच्या जागी 2 ठेवा, which is less than x, which is less than 1/2 raised to 2. Means again it has a value क्लोज टू 0 होता है. देखो इस तरह से this goes to continuously discontinuous function. In this way, if we take the continuous value up to n, अगर हम n रखते हैं तो क्या होता है, देखो n की जगह पे आप रखते हैं तो क्या होता है, n इज इक्वल टू 1. यू कैन पुट n प्लस 1, अगर n माइनस 1 यहाँ पे n माइनस 1 रखते हैं तो f ऑफ x इज इक्वल टू 1/2 रेज टू n माइनस 1. when if we put n is equal n की जगह पे n माइनस 1 रखना है तो 1/2 रेज टू n which is less than x is less than 1/2 रेज टू n माइनस 1. एंड कंटिन्यूइंग इन दिस वे, इसको फिर आप कंटिन्यूएशन जाओ डॉट डॉट डॉट, then finally if we going on the increasing the power f of x, if we put infinity in this way, we going on increasing, then we put f of x is equals to, आता हा डिनॉमिनेटर वाढत चाललाय, 2 raised to 2, 2 raised to 4, 2 raised to 6, 2 raised to 8, 2 raised to n up to the 2 raised to infinity. Means denominator is going on increasing. If the denominator going on increasing continuously, then the value of that fraction goes to the decreasing and decreasing, which goes to the nearer and nearer to 0. तुम्हाला लक्षात येतं का? पहा, डिनॉमिनेटर जर वाढत वाढत चालला तर त्या फंक्शनची व्हॅल्यू कमी कमी होत चालली. आणि ग्राफवरनं बघा, ग्राफवरनं बघितल्यानंतर तुमच्या लक्षात येतं की ग्राफवरनं बघा तो क्लोज टू फंक्शनची व्हॅल्यू क्लोज टू 0 चालली. अगोदर 1 ला होता, 1/2 ला होता, 1/4 ला, 1/8 ला, असं करत 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 0 ला जातो. मीन्स f ऑफ x डॉट 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 f ऑफ x is equals to 0 when x is equals to 0. Thus we notice that f is bounded. Here we found that the function f is bounded. डायग्राम काढा रे सर्वांनी. And monotonic increasing in closed interval 0 to 1. And according to the theorem we have seen, अगर monotonic increasing है, function monotonic decreasing है, ओके. आता हे तुम्हाला monotonic increasing कसं वाढेल, जर n ची व्हॅल्यू फंक्शन 0, 1/2, 1/3, f of 1, f of 2, f of 3 n ठेवला असता, फंक्शनची व्हॅल्यू मोनोटॉनिक डिक्रीजिंग आहे. ठीक आहे. जर फंक्शन मोनोटॉनिक इन्क्रीजिंग किंवा डिक्रीजिंग असेल, मोनोटॉनिक असेल, इट मे बी इन्क्रीजिंग और इट मे बी डिक्रीजिंग. सो आय शॅल राईट हिअर मोनोटॉनिक. सो द फंक्शन f of x is monotonic, bounded and monotonic इन्क्रीजिंग 0 ला 0 आहे आणि 1 ला. इन्क्रीजिंग कशामुळे आहे लक्षात येतं का रे तुम्हाला? f ऑफ x ची व्हॅल्यू 0 ला 0 आहे. तुम्हाला वाटेल डिक्रीजिंग, असं ग्राफमध्ये बघितलं तर डिक्रीजिंग नाही. f ची व्हॅल्यू, x ची व्हॅल्यू 0 असताना f ऑफ x ची व्हॅल्यू 0 आहे आणि x ची व्हॅल्यू 1 असताना f ऑफ x ची व्हॅल्यू 1 आहे. म्हणजे इन्क्रीजिंग आहे. लक्षात ठेवा, x ची व्हॅल्यू वाढत चालली तर f ऑफ x ची व्हॅल्यू सुद्धा काय होते, वाढत जाते. म्हणून फंक्शन इन्क्रीजिंग आहे. आणि हेन्स बाय द थिअरम 5, the function is integrable. Monotonic increasing function है, it is a bounded है. Bounded means lower bound is 0, upper bound is 1. So we can say that function, according to this theorem, the function is integrable. Okay, and hence proved. अशा पद्धतीने इथं थांबू. हा पार्ट महत्त्वाचा आहे. आता नेक्स्ट पार्ट आपण उद्याला सुरुवात करू. आपलं लेक्चर आता रेग्युलर सकाळी 9 ते 10 असेल. कोणीच मिस करायचं नाही. ओके, नाउ वी शॅल स्टॉप हिअर. एकदा स्क्रीनशॉट घे रे वैष्णवी, कोंपले सर्व स्टुडंटची एकदा स्क्रीनशॉट घे. प्रत्येकाने प्रेझेंटी टाका रे. एकदा 2 मिनिटामध्ये प्रत्येकाने प्रेझेंटी टाका. मला कोणते प्रेझेंट आहेत स्टुडंट पाहू द्या. आणि वैष्णवी कोंपले तू प्रेझेंटी घे. यस, सर्वांची अटेंडन्स टाकल्यानंतर प्रेझेंटी घे. 2 मिनिटामध्ये मी पाहतो. मी तोपर्यंत एकदा रिवाइज करतो हा प्रॉब्लेम. सी दिस, show that the function f is given by f of x is equals to 1 upon 2 raised to n. The condition is 1 upon 2 raised to n plus 1 is less than x is less than 1 upon 2 raised to n, and f of 0 equals to 0 is integrable on closed interval ab. Actually the given function is bounded. One theorem we have proved, if a function is bounded and monotonic, it may be increasing or decreasing, then definitely we can say that it is integrable. अभी देखो यहाँ पे फंक्शन बाउंडेड है. अगर फंक्शन बाउंडेड है तो हमें क्या प्रूव करना है? इट मे बी, नाउ वी हैव टू प्रूव दैट इट इज इंक्रीजिंग और डिक्रीजिंग, दैट इज मोनोटॉनिक. So we have given the function f of x is equals to 1 upon 2 raised to n, and under this condition, now first of all put n n is equals to 0. अगर n is equals to 0 लिखते हैं तो सी दिस, अगर n is equals to 0 पुट करते हैं तो f of x is equals to 1 होता है, और उसकी रेंज 1/2 is less than x is less than, f of x is 1/x is less than 1, and 1/2 is less than x is less than or equals to 1. हॅलो, थांबा जरा, ऑनलाईन लेक्चर चालू आहे, एकच मिनिटात लावतो. f of x is less than 1, f of x means 1/2 is less than x is less than 1. That means the value of f of x is 1 if it is in between 1 to 1/2. But 1/2 side is open and one side is closed because less than or equals to. In this way we obtain f of x is equals to 0 when x is equals to 0. This shows that the function is monotonic and hence it is आता पाहिलं तर function is discontinuous at different points, at infinite points the function is discontinuous, but it is a monotonic increasing. Then by the theorem we can say that it is the integrable and hence proved. Okay, now